Hello everyone, this is Natraj. I'm back with another video. In this video, I'm going to talk about that provisioning the GCP file store with the Terraform. What is a GCP file store? GCP file store is a fully managed network file system service is provided by the GCP cloud. It allows you to mount the shared file system to the multiple compute engine or GKE pod using the standardized NFS protocol v3 or v4. Ideal for shared storage in Kubernetes GKE, it is used as a persistence volume for the multiple pod. It great for stateful application like WordPress. Next one is the stateful workload in the compute engine. For example, you have multiple VMs share the common directory for the log or data or configuration. It is the best one. Next one is the CI/CD pipelines. You can build the agent can share the temporary build artifact using the NFS. Next one is the key features. Fully managed, no patching, automatically scaling up, and also that reducing the operational burden by 80%. Next one is the guaranteed performance. Yeah, it's delivered the consistency IOPS and throughput for the all the applications. Next one is that highly availability. It offers that 99% of availabilities and ensure the business continuity. Next one is that scalability. It dynamically scaling the capacity from 1 TB to 1 PB without downtime. Next one is that cost effective, pay as you go pricing model. There is no upfront hardware investment. Next one is that integration. It can integrating with the compute engine or GKE within the GCP cloud. Architecture diagram. Using the Terraform to create the GCP compute engine and mount the GCP file store volume across the multiple instances. Repositories. Yeah, you can download my Terraform code from these below links. Comparisons with the cloud storage persistent disk. We can see the one by one service. The first one is the file store. When the multiple VM or multiple pod need to be access the same file at the same time, then the file store is the best one. The file based NFS is means you can get the directory structures. The file store is offer the low latency, especially for the same zone as the compute resource. Next one is the persistent disk. It is a block storage. It is ideal for attaching to that single VM as that booting device. Yeah, you cannot share the disk to across the VM. Mainly used for database, storing the log and locally. Next one is the cloud storage. Yeah, it is the object storage solutions. It is not the mount like that disk. It is the highly durable, great for backupping and static websites. So the latency is highly compared to that file store and persistent disk. We'll be moving to the Visual Studio Code. We can derive that Terraform code. So we are at the Visual Studio Code. We can see the file one by one. The first one is the pro.tf file. Here the key points we'll discuss. I specified the Google provided 6.17.0. This version can differ. Next one is that I'm using that my own service account credential for that Terraform credential.json file. Here I am provided that necessary privilege to create the resource. From your case, this credential should be have to be create your own. Next one is a project, region and zone. According to my scenario, I defined that those things. Now I am moving to that variable.tf file. I define the input variable for reusabilities. For example, project ID, region, GCP service list. So according to your scenario, you can able to provide those value. Next one is that file.main.tf file. The first resource, Google project service resource. Here I am enabling that file storage API service. Next resource is that Google file storage instance. we can see the key configuration tier. I choose with that base underscore HDD is the lowest costing option. The capacity I defined is minimum with that 1024. So this is the minimal capacities. Next one is the network. Using the default VPC with the default pairing I am using here. Next one is the security part. So I'm open the widely access, but it's a production grade application is not recommended one to open to the globally. So next resource is the data block. So here I am fetching the latest Ubuntu 22.0.4 LTS image. So this version also according to that it can change. Then I extract that file storage IP address from the VM startup scripts using that local function. The next resource is the template processing. Here I reading the startup script TPL. So here I am injecting the file store IP address to the script, and finally I am rendering that startup script for the VM. Next resource is that creating the compute instance. Here I am creating the two ideal VMs like VM instant -0, VM instant -1. Then I am assigning the external IP address to those VM. Finally I am run the startup script to the mounting the file storage. Yeah, next file is that startup script.tpl. Yeah, here are the key points. So I'm updating the package, then I'm installing that NFS client package, then I'm creating that mounting point directory, finally I'm mounting the file store. So these are things happening on the during the running time. Next one is that output.tf file. The main purpose of this file is displaying that file store IP address for the after deployment. Okay, so this infrastructure I am creating the shared storage solution where with multiple VMs can read and write to that same file store. So while moving to the terminal, new terminal, just I am elaborating the screen. So Terraform planned and already executed, so I'm skipping those things, and now I'm moving to the Terraform apply command here. Yeah, it asking that user inputs. You can see the thing, the plan is 4. It's going to create the new resource. Just I'm providing the user input is yes here. Yeah, now the resources creation is going on. It takes some 2 minutes to complete this entire operations. Yeah, Terraform operation successfully completed. So we'll moving to the Chrome browser, validating the GCP instance VM. I'm at the browser. I'm logging to the GCP console according to my projects. So now I'm going to see at that file storage. I'm going to type on file store. Yeah, here it will be showing on it. Just I'm going here. Yeah, you can see here the file storage instance is created. It's a test instance, whichever name I defined from my Terraform. Tier also the base underscore HDD, whichever I defined, it's showing on. Yeah, the capacities, everything is visible here. It's properly created. Now I'm moving to that VM resource. Yeah, two ideal instance is created. So I'm going to log in with any one of the machine. I click with the SSH. Now the connection is established, is going on. Yes, so I just am executing that df-h command to list that entire disk. See here, this mounting point is properly mounted. So this is my file system storage IP, along with I mounted with the /mnt disk file store. This is an efficient way to mount that volume. I hope this video will be useful to everyone. Thanks for watching. Bye.